Hello again, and welcome to Advanced Physics Online for Lesson 5 of Unit 1. Tonight we're going to be talking about how to solve a more difficult electrostatic force problem, as you can see. All right, so what we have in this situation, we have four charges as shown below. Find the magnitude and direction of the electrostatic force on the 6 nanocoulomb charge. N stands for nano. Anything N, that means times 10 to the negative ninth. So it would be times 10 to the negative 6 times 10 to the negative ninth coulombs. All right, so let's go ahead and just look at the four different charges. And I'm going to go ahead and label them so it's easy for us to talk about A, B, C, and D. And so we're looking at the charges on D, or the force on charge D. And so I'm going to go ahead and draw those in there. So A, as you can see, comes down here at this angle like that and exerts a force on it in that direction. It'll be a 45. That's a 5-5-5 triangle. So that's going to be 45 degrees at that angle. So 45 coming in. And then we have B down here, and I'm going to draw him in a different color. Now it's a little bit closer. It's only 0.5 apart. And it's the same, so it's going to be a little bit bigger than that previous one. So I'm going to draw it just a little bit longer, but going in that direction. And then last but not least, we have C here. And C is the same distance as A is. It's going to be a little bit less because it's only 2 nanocoulombs. So I'm going to reflect that here. Just a little bit smaller. Okay, so I want to find the resultant of those three. So this should be a little bit of a review from your pre-calculus. And so the first thing we need to do is find the value for all three of these. And we're going to use the equation that we've been using from the previous days. We're going to use force equals K times Q A times Q B divided by D squared. And we're just going to do that for all the four different ones. Okay, so I'll go at, we'll start with the blue one by B. That's the easiest, that's the simplest one to do. So we got force by B on D. So we just plug in the numbers there, and I'm going to go fairly quickly through this. So you may actually want to pause it if I go a little bit fast, and make sure you check to see if your calculator works. Times 10 to the ninth. So you go ahead and plug in your values. You got 3 times 10 to the negative ninth times 6 times 10 to the negative ninth divided by 0.5 squared, and you get 6.48 times 10 to the negative 7th newtons. So let's go ahead and do that for, I'll go ahead and do for letter C, and then I'll do that for part A again. And again, if you need to pause it, feel free to pause it, because I'm going to go quickly. I'm just going to solve that equation for each of these. And then we'll move on from there. Now, as I start this part, now we don't know the value of our distance from here to here. So the question is, how do you find it? Well, we can use our simple our geometry lessons to do that, because we know that this is 0.5, that's 0.5, and we're trying. And it's a right triangle. So we can use a squared plus b squared equals c squared to find our distance here. So a squared plus b squared equals c squared. So we'll put 5 plus 5 c squared. And when you solve that out, you get an answer of 0.707 meters. So that's going to be our distance here between those two. And don't forget to square it. And when you do that, what you get an answer of is 2.16 times 10 to the negative 7 newtons. All right, so there's our next one. And then we got to do one more. We're going to go ahead and solve for the force by A, this one right here. Oops, wrong color. Right here. There we go. And so let me go ahead and do that. So force by A is equal to, and I'm going to go ahead and just solve that. So as you can see, force by A is 3.24 times 10 to the negative 7th. Now you can do a real quick reality check here, and it shows by A should be bigger than C, but B should be bigger than all those, and that all checks out. If you check all these three, they do line up with our logic. Now, if we notice here, like the one off from A is going down at an angle like this, where you're looking at a 45-degree angle. Okay, we need to get a resultant so we can combine all three. So we're going to have to break this down into its two components. Also, we got to do the same thing to this one. If you notice, it's going up at an angle of 45 degrees, and we need to break it into its components so we can combine those terms. So that's what we're going to do in our next slide here. So we'll pick up here the blank page. All right, so we'll go ahead and start with our by C, and it's going up like this. Again, 45 degrees. And we want to find our x's. Here's our x direction and then our y direction, like so. And we know that this value here is 2.16 times 10 to the negative 7th. Sorry about that. I'll have a better copy of this later. So what we have is a 45-degree triangle. So if we use the sine of 45 to find our other side, equals y over 2.16 times 10 to negative 7 newtons. Now what I used there was SOHCAHTOA. And if you weren't in my class last year, we went over this extensively. Come and see me, and I'll give you more example problems of this to help you out. So when you go ahead and solve for y of that component, you end up with is 1.84 times 10 to the negative 7th newtons. And the x component would be the exact same thing because it's a 45-degree triangle. You can go ahead and plug it in if you want, and you'll get the same result. So let's come over here by A. Similar thing. Get the triangle going down, and you want to find the two components. And we know that this value is 3.2. 4 times 10 to the negative 7th. And so we do the same thing again. Sine of 45 equal to y divided by that number. So there you go. There's our results for these things. Now, we need to combine all these together. Now let me show you the picture of what we have going on. So we've started off, and this hasn't changed. We got our 6.48 times 10 to the negative 7th, like that. We have our black component, not quite as big, 2.76 times 10 to the negative 7th in that direction. And then we have our green component, a little bit less than that one, at 1.84 times 10 to the negative 7th newtons. Then we have coming down the same value. These two are equal. The same value, 1.84. And then we have our going up slightly bigger. These two are equal there, like so, going up. So now what we got to do is we got to turn this into one gigantic triangle. So we got to add these together, and we're going to subtract these two right there. So when you add these top three together, because they're all in the same direction, you get 11.08 times 10 to the negative 7th newtons. And then if you combine those two together, subtracting them, you get 0.92 times 10 to the negative 7th, like so. And so what you end up with is a triangle that goes over 11.08, 10 to the negative 7th, and it comes up just a little squinty thing at 0.92 times 10 to the negative 7th. And then our resultant, I'll draw in red here, is going to come up like this. And we want to find that value right there, and we also want to find that angle, which is our next step, which we're almost done, and that gives us our complete answer for this next problem. So this last part's actually fairly simple. We're going to use the a squared plus b squared equals c squared principle with these two here and here, and we're going to go ahead and solve this out. So 11.08 times 10 negative 7th squared plus 0.92 times 10 negative 7th squared equals our c squared. And that equals 1.1 times 10 to the negative 6 newtons, like so. And now we just got to find the angle. So we can use our tangent function, because we know our two sides, to find that angle. Tangent of theta is going to be our opposite, which is 0.92 times 10 to the negative 7, which we can drop those times 10 to the negative 7th, because it's a division problem. If you plug it in your calculator. And when you get that, you solve that out, you get an angle of 0.08 degrees. Now, if you try that, you notice that I just made a mistake, one of the fundamental mistakes, and that was just to illustrate what you're not supposed to do. Does anybody know what the mistake is? Sure, you out there in the audience, you know what it is. I had the calculator in radians because I was taking my calculus class earlier, and I left it in there. That is not actually, that's the answer in radians. The answer in degrees is equal to 4.7 degrees. And that's above the 0 line. So our final answer is 1.1 times 10 to the negative 6 at 4.7 degrees. That's going to be the force. If we go all the way back to the beginning, that's going to be the resultant on C. If we looked at our C, or actually on D, it's going to be up and over about like that because of those three forces. All right, so that's it. I'll maybe do another one of these if you guys have trouble for you all. And in class tomorrow, we will go ahead and work on these together. So good luck. Have a great night. See you tomorrow.